Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Jason Oakley, our WIEPRO consultant, our internal process engineer, and we'll be talking about system and overall efficiency. Hey, Jason, thanks for being on today.
Thanks for having me back, Cully. Happy to be here.
Anytime, man. So today we're going to be talking about system efficiencies and how our SEW product plays a role in those. So when we're talking about system efficiencies, it's kind of like our customers' application, their procedures, their lines. So anything that has multiple components. And if efficiency is important to them, what are some of the things in those applications that could play a role in overall system efficiency?
Yeah, good question. Basically, starting from incoming power to the frequency drive, to the gearbox, to the motor, transmission types, sprockets, chains, and even your conveyors all make up a system, and all of it together are what your total system efficiency will be.
So there's multiple components. I'm assuming each one has their own efficiency. How do they play a role with each other? And then how do they add up into the overall efficiency?
Exactly. Yeah. All of them have their own efficiency rating or level, and those efficiencies are multiplied together to get your total system efficiency.
So if we're looking at each one and one, say, has 50% efficiency, then that's immediately going to cut your overall efficiency in half since it's multiplied across.
Exactly. Yep.
Wow. So if we're looking at the overall thing, you said frequency drives, mechanical components. If there's a mechanical speed reducer or variable speed drive compared to a VFD, a variable frequency drive, how would those compare? And if they do the same job, which one should a customer choose if they're concerned about efficiency?
Yeah, efficiency there, the better option is going to be your VFD. That's the newer technology, the more efficient rated device. That's going to be in the high 90s percentage-wise versus your variable speed or belt kind of driven reducer. That's maybe half of that. It's an older technology and it's very inefficient to use.
And just going back to the point we made earlier, if it's going to be half of that, you're just absolutely sabotaging your overall efficiency. So when we want to replace our mechanical variable speeds with VFDs just for that overall efficiency. And one thing that SEW is definitely concerned about when it comes to efficiency is our gear motors, because that is kind of our bread and butter along with our VFDs. So if we're looking at a gear motor, there's two parts. We have a gearbox, we have a motor.
Yep.
So how do our motors play into it?
Yeah, there's a bunch of different options there. We have some efficient motors. We have some premium efficient motors. And of course, to get the best and the most efficient motor and use it properly, you're going to look for applications that are continuously running, like an S1 duty type application. That's going to be your best bet to get the most efficiency out of a motor.
Awesome. So premium efficiency motors are going to play a role in this, and they're going to really shine when they're running a long time under a constant load. So we have our motor and then we have our gearbox. I'm assuming, gearboxes are pretty much all one and the same. So do they all have the same efficiency setups?
There's actually pretty big differences there. There's some types of gearboxes that are using a sliding contact in the gearing, as well as other boxes that are using a rolling contact, and one is more efficient than the other. So that all depends which gearbox you select affects your efficiency in your system overall.
So with the sliding, it sounds like we're talking more of our worm gearboxes.
Exactly. Yep.
And then the other ones, we have our helical bevels. And I mean, just off the top of my head, I know those worm boxes can be anywhere from 60% efficiency, and the helical bevels sit in the high 90s. So once again, you really have to pay attention to the overall system. So gear typing, only thing we're concerned about when it comes to our gearboxes?
A few other things to consider, your mounting position, how your gearbox is mounted, oil levels, oil type. These things affect the biggest losses or inefficiency there is something called churning losses. So if you have a gearbox that's full up with oil, it's going to be a little bit harder to kind of churn through that oil, so be less efficient, more heat's involved there, or versus a gearbox that's a little bit less oil, and that all depends on how you're mounting the gearbox.
So if our customers have our gearboxes out there, they should be very aware of the amount of oil we recommend for a gearbox.
Exactly.
Not just so it's too little, but also if they put too much, they're hurting the overall efficiency.
Exactly. Yep.
So we've talked, gear motors, VFDs, all these controls. If we have a customer that's very concerned about efficiency, is there an option out there that we've seen used in the field, or kind of maybe one of your favorites?
Yeah, one of the best options when we're focused on efficiency and changing systems is our Movigear product. It's an IE5 rated product. It's a synchronous servo motor built into the gearbox and a controls or a VFD all built into one. So it's a very efficient setup. And usually you directly mount this right to a conveyor. So we're eliminating all those sprockets, chains, extra belts or pulleys or whatever the situation in the previous version may have called for. So it's a very efficient. You eliminate a lot of different inefficiencies in the system and create a more efficient system.
So with that, mounting it right up to the application, eliminating those mechanical middlemen, if we will.
Yep.
Then it sounds like when we're looking at overall system efficiency, we want to have some more electronics, VFDs for speed control, and the more steps we can eliminate is the less we have to multiply out.
Exactly.
Thus losing more efficiency.
Yep.
Is there anything else we need to talk about overall system efficiency or how SEW plays a role in that?
For now, I think we're okay. We can certainly dive in more later if we need.
Awesome. Well, thank you again so much for being here.
Thanks a lot.